Um, how do I do it?
Not sure. So, um, might be a bit too involved to begin with. It should be okay. Well, we'll start simple and we'll go. We might come back to it. Okay. Go back. Okay, so here's just kind of bare bones simple. Any idea about this one? FG of 2, any idea what that means? So if they said F of 2 or G of 2, I think you would know how to do it. Any idea how you
Yeah.
do FG of 2?
Is it just substitute two into both equations?
No. So what it means is you substitute, so the FG of 2, that means you sub 2 into G. So you do the G of 2 and you sub your answer into F. So what would be the G of 2? How would you do that?
3.
Yes. And so the F of G of 2 is the F of 3. And what is the F of 3?
Um,
Sorry?
10.
Sorry. I thought you said M. Yeah. And now, so that's the FG of 2. How about the G of F of 2?
G of F of 2, same thing, but this time you put 2 into F, and then whatever the answer is into 2.
Yep.
So you get 18.
Okay, so then it's the G of 5, 25. Yep. Yep. And then how about last one, the F of 2?
We do the F of 2, and then whatever the answer is, go back into F.
Yep.
So we get 5, then 5 back in, we get 26.
That's it. Any questions there?
Mm.
Okay. 26, 10, 18. Okay, this time you have to do, instead of the F of G of a number, like 2, you have to do the F of G of X. Any idea how that would work?
No. No.
Well, what is the G of X?
2x minus 1.
And so
What?
that is what you have to put into F. So the G of X is 2x minus 1, and so you have to do the F of 2x minus 1. How would that work?
Put 2x minus 1, substitute that for x.
Yeah. And what would you get?
Um, (16x squared minus 16?
So you're way ahead of me. So what would be the first step?
Put 2x minus 1 into x.
Yeah, and so you'd get 2x minus 1
4.
plus 4. That's all squared. Simplify.
Four x squared minus 5.
Okay, so 2x plus 3 all squared.
Yeah.
How do you expand a square bracket?
Oh, it's 2x. Oh, yeah. Should have done that. Yeah. 2x plus 3, 2x plus 3.
Yeah.
So you get 4x squared plus 12x plus 9.
Yeah. So you got the first one, you got the last one, it's just the middle two. Okay, any questions there?
No.
Yeah, so instead of subbing in a number, you're subbing in an expression in terms of x. Okay. Oh, technically they didn't tell us to expand it. Fair enough. Okay, this time we have reciprocal. So we won't bother simplifying too much. Let's just... what is the f of g of x? Sorry, g of h of x and h of g of x. Sorry.
What was the question?
The g of h of x and the h of g of x.
So the g of h of x would be 6 over then that 2 x plus 5.
Yeah, so 6 over 2 over x plus 5. I'm happy enough with that.
And then the other one would be 2 over 6 over x plus 5.
6 over x and then plus 5 is separate. If I do keep, change, flip for this one on the top, I get 6 times x plus 5 on top and 2 on the bottom.
Yeah.
What does that simplify to?
3x plus 15.
Yeah, okay. After you expand it. This one down here, let's see. If I multiply the top and bottom by x, would that be the easiest way to do this? I would get 2x over 6 plus 5x. Will this be more trouble than it's worth? If I multiply the top and bottom by 6 plus 5x, okay, it's more trouble than it's worth. Okay, so if I had gone through that whole laborious thing, we would get the same thing twice, and there's some significance to that, which we'll see later. This one, I think you're going to be okay for this. Let's just check. I think you're going to be fine there. The only thing that's worth doing there is nothing. You're fine. Okay, exam question.
So substitute 1 into 2 x, so you get 2 minus 5, which is minus 3. Then is minus 2 plus 5 plus 4, which is minus 10.
Looks good. So that was just part 1. Another exam question. Numbers are a bit trickier. I think you'd be okay for it, am I right?
Yeah.
Yeah.
Do you want me to do it though?
No, I think you'll be fine. There are negatives, but nothing more than that. This one, numbers are a bit trickier, but I think you'll be fine for it. This one, numbers are a bit trickier. Do you want to try these, or you think you'd be okay with them?
Yeah, it's just the same thing, isn't it?
Say it again, sorry?
No, it's fine.
Yeah, okay.
Just the same thing.
Yeah. Fine. Let's see, the graph of this. Find the exact coordinates. Okay, let's try this one.
The graph of y equals fgx meets the x. Find the exact coordinates or points at which the graph of y. So dx there. So put 3. Bracket 3x plus 7
Mm-hmm.
minus 2. Let's find out. We get 9x plus 21 minus 2. We get 9x. 9x plus 19.
Yep.
And then we just find out x.
Well, that is the f of g of x. They want to know where the graph of y equals the f of g of x will meet the x-axis. How would you do that?
Make x equals 0. Or y.
Which one?
Find out x. Make y equals 0.
Correct. On the x-axis, y is 0.
Yeah.
And
So
y equals
9x.
the f of g of x.
So 9x plus 19 equals 0.
Yeah.
9x equals minus 19. X equals minus 19 over 9.
Yep. That's it. Any questions there? Okay. I'm glad we skipped all the easy ones. Easy. Let's see this one. The functions. Oh. Hang on. There we go. Okay, let's try this one.
Given that g f of x is less than 5 of those, find the statistical area. Okay, so f of x. So we put 4x squared. Okay, so a bracket 4x squared minus 12x plus b gives us 4ax squared minus 12ax plus b, which is just drop it, isn't it?
Which is what, sorry?
Then what do we do after that? Do we factorise it?
Can it be factorized?
You can take ax out, so then you get 4ax minus 12.
What else could you take out?
4.
Yep.
4ax bracket x minus 3 plus b.
Okay, what will be next?
That all less than 5.
Yeah. Unless I'm mistaken, there may not be a way for us to solve this. I think I need a second thing. So you can see here question 9 part 4, and I think I might have cut too much off this question, like we needed something. Sorry.
It's fine.
9.
Function f and g defined by that. show that GF 0.5 equals 2.16. Explain why FG 0.5 is not defined. Okay, so so 2 sine 0.5 gives you. Do I need to be in radians or something before?
You tell
Or is
me.
it alright? It's going to be radians, isn't it?
So if you look at their domain, they have pi,
Yeah.
so that's going to be radians.
Yeah, how do I get to radians to set up?
Which
Okay,
calculator?
so
Oh, you have it?
yeah, it's quite bougie. 2 sine 0.5 gives you 0.95885, so then wherever that is. So 4 minus 2 ants squared gives us 2.16. Oh yeah.
So 2.16 to 3SF.
Yeah.
Okay, and explain why the f of g of 0.5 is not defined.
FG, so G 0.5, so 4 minus 2 0.5. It's probably not going to be in the range, is it?
That's my guess as well.
So 2 sine 3.5. Yeah, it's not in the range.
Any idea about this one?
It's out of the range. It gives you minus 0.7 and the range is half pi.
Okay, so the domain.
Yeah.
Okay,
Out of the
the f of 3.5 and a half of pi. So pi is 6 point something. Sorry, pi is 3.14, so half of that, so it's outside the domain.
yeah.
Yeah, undefined outside the domain. Any questions there? Okay. And if we really wanted to, we could say you'll be fine for both. Oh, there might just be something at the end of this. Yes. Let's try just part C.
X.
Is that because you saw the answer?
Yeah. No, I'm trying to work it out. Find
Wait.
expressive of G F X. Oh, it's just a thing, isn't it? So you put 2x plus 5 brackets, then minus 5 over 2. Then 2x plus 5 minus 5 gives you 2x. 2x over 2 is x.
That's it. So that's equal to x. What would be the f of g of x?
So 2.
Can you hear me? Hello? Again, and what that tells you is that these functions are inverse functions. So basically the g of f of x, you put in x, you get back out x, and so they're the inverse of each other. And if you look at the two of them, the first one is times by 2 and then add 5, and then the second one is subtract 2, so like in reverse order, first you subtract 2, and then you subtract 5 and then divide by 2. And so those are called inverse functions. Yep, so we can write it as the f of x is 2x plus 5, and the f inverse of x, it's a bit like inverse sine, cos or tan, f with the little minus 1. Yeah. Okay, read that, tell me what you think.
Okay, show that f7 equals 20, so 3 times 7 is 21, 21 minus 1 is 20. Hence, write down the value of f minus 1, 20. Okay. The value of f minus 120 is just the same, isn't it?
The f of 7 is 20.
Yeah.
What is the f inverse of 20?
7?
Yep. That's how inverses work. So it just undoes what you did. And if we go back, copy. Which of these is the f inverse of x for this function?
What? What's the inverse of for that function?
Yeah.
3x minus 1, so it's got to be a plus 1. Is it C?
Correct. C. Got it. C. Yep. I think we'll just jump into it and we'll figure it out. So for all of these, so you can see f of x and down at the end f such that x maps onto. It's pretty much the same as the f of x equals. You can treat it the same way. The way to do these, number 1, replace f of x with y, just for the sake of simplicity. 2, swap y and x. 3, make y the subject. Excuse me. And 4, replace y with f inverse of x, because that's technically what they asked you to get. So try that for part A.
Okay, replace fx with y. So y equals 4x plus 3.
Yeah.
Swap y and x. What do you mean swap y and x? So x equals 4y plus 3.
Yeah, so that's the thing that we saw a second ago. The f of 7 is 20, the f inverse of 20 is 7. So for inverse functions, the x and y are swapped over.
Y the subject, so x minus 3 over 4 equals y.
Yep.
Replace y with f minus 1 of x. So f minus 1 of x equals x minus 3 over 4.
Yeah. And let's see, f minus 1 of x. I don't think any of those will give you any trouble. B or C, am I right?
What does that thing mean again? Is it just the same thing?
It's similar.
General.
You can treat it the same way.
That like sign that's like looks like an arrow.
F
Done.
such that x maps onto. So it's another notation for a function.
F such that x maps on. So it means the same thing.
Yeah, very similar.
Similar.
So I don't want to get into it. It's like the difference, like y equals and f of x equals. For each rule, any of those you want to try, or you think you'd be okay?
Same thing, just y equals 10 minus x, and then you just do it like that.
Okay, I think you'll be fine. Let's see. Inverse exists for any one-to-one function. If a function is many-to-one, then there's no inverse function. Okay. Which of these functions will not have an inverse?
Both. Isn't it?
Will have an inverse or not have an inverse?
Won't. Aren't they
Why
both? Aren't they both many to one?
why is that? So if you were to sketch the graph,
Oh wait, I just remembered what that meant. So x squared minus 5 is just, yeah.
and so it'll be the same graph, but it has a different domain. So that's starting from when x is 1. So it might be like there to there or something. So which will have an inverse?
B,
Why is that?
because it's not many to one.
Correct. There's no y coordinate that repeats, and so this
Yeah.
will be 1-to-1. So
Yes.
the other one will be many to one. When you put in 3, you'll get the same answer as when you put in -3.
Yeah.
And so because it's many to one, you won't have an inverse function. Okay. Let's try this one.
Write down the value of G3.
And use the graph for that. There's no function.
So when x equals 3, y equals 2.
Yep.
G minus 1, 3 is 5.
Well done.
G minus 1, 4 is 6.
Yeah.
And G minus 1 is -2.
Yep. Part
Why is it
B.
not possible? Why is it not possible to evaluate G minus 1 then? Because it's not on the graph?
So yes, it's outside the
Oh yeah, it's out of the domain.
outside the domain.
What is the domain of the function G minus 1?
I think technically it's outside the range, you would say. Maybe I'm wrong. Yeah, because the inverse is the y, and so that's outside the range. Okay, go on. See.
What is the domain of the function G minus 1 less than 2? Minus 1 to 4. Yeah.
Say it again.
4.
Yeah.
And then just sketch the graph.
Hang on. Part D, the range of the other one.
Oh, isn't that just what we just did? Oh, what's the difference? Oh, what's the range in G minus 1? What's between the range and the domain?
The domain is the x, and
It's
then the
dropping
range
out.
is the y. Say it again, sorry.
So is the range the outputs?
Yeah. This is the output of the inverse function.
Yeah, okay. So outputs would be -2 less than equal to x, less than equal to 6.
Yeah, and it wouldn't be x, it would be y. And even better still, I'm going to write g inverse of x. And the easy way to do that is find the domain and the range for the function, and then for the inverse function you can just swap the x and y, because that's what an inverse function is. And then sketch the graph of y equals This, how would you do that?
Just look at that graph. Are you allowed to look at that graph?
Yeah. It's necessary.
So -1 goes to 0. Does it?
Yeah.
0 goes to 1.
So let's say, see this coordinate up here, 6, 4?
Yeah.
Where would that be on the new graph?
Oh, mine's gone.
Or I'll take a better one. 3, 2. What do you know about inverse functions?
Does it just flip?
And so what would it be?
2, 3.
Correct. You swap the x and the y. 2, 3. So that's what it would be on the new one. So use that to plot all the points you can.
Okay. Do you actually want me to draw it?
No, just tell me the coordinates.
Oh, okay. So if that one's -1, -2, so then it'll be it'll be -1, -2.
Mm-hmm.
Then 0, -1.
0 minus 1. Okay, yeah. Go on.
And then if that one's 0, it'll be 1, 0.
So that's going to be 1, 0. And I think that's all we can fit onto our graph. And it's going to be something like that. Anything you notice about the two graphs? Probably don't.
What I notice?
Yeah. Any pattern you can notice about the two graphs?
No. Well, it's just rotated a bit. No, it hasn't.
It's a reflection in the line y equals x. And the reason for that is because it's literally you swap y with x and x with y. And so function and inverse function, the graphs are always a reflection in the line y equals x, and it's because you're swapping x for y and y for x. Okay. 10 is not in the range. Yep. G inverse of y. Okay. Let's see. For each function below, using the same scale, sketch these graphs. I think it'd be okay. Find an expression for the inverse. Find the domain. Okay. So for this one, add the graph. Nah, it's okay. This stuff, so this is to do with the graphs. Yep. Okay, let's try this one.
Function f is defined for x is greater than or equal to 0 by f of x. Find an expression for the inverse f minus 1x. Sketch the graph. So if we substitute f of x for y, we get y equals x plus 1 squared plus 2. Then we swap the y and the x, so we get x equals y plus 1 squared plus 2. Then we make y the subject, so x minus 2. Oh wait, no. So we square root of
Sure, yeah.
square root x gives you -y plus 1 plus 2. So square root x minus 3.
Nope. If you were to square root both sides, it would be root x, it would be root of the bracket and the plus 2. So you would have to get the square bracket, make the square bracket the subject first, and then square root. So go back to your original way. x minus 2 equals, and then square root both sides.
x minus 2 equals y plus 1 squared, then square root, so we get square root x minus 2 equals y plus 1, then root x minus 2 minus 1.
1. Yes, and so minus 1 minus 1 plus root x minus 2. Yeah, go on.
Then f minus 1 x equals that.
Yeah, and equals f inverse of x instead of y. They limited the domain to x is greater than or equal to 0. That's why we don't have the plus or minus the square root.
Okay.
Okay. They want us to sketch the graph. How do we do that? Would you know the graph of y equals root x?
No.
So y equals root x looks something like that. And so if this was a transformation, how would you transform the graph of y equals root x onto y equals minus 1 plus?
Reflection.
I don't believe so. So it will be a reflect. Oh, okay. Maybe I'm being too pedantic. No, I'm not. So x became x minus 2. What will that do as a transformation?
Oh my god, which button? Go to the left 2 or go down 2?
If it's right next to the x, that'll be in the x direction.
Okay, so go down 2.
That's the y direction, down.
Oh, yeah. Go left 2. Go left 2.
You don't know your transformations. It would be right 2. It's always the opposite when it's right next to it. So, and the minus 1 for the y direction will be down 1, not up 1, because if you were to bring it to the other side, it would be y plus 1. So this graph, it's begins at the origin. If it moves 2 right and 1 down, it's going to begin there, something like that. That's 2, that's minus 1, and then it's going to be a similar type of graph. Okay, and state its domain.
I don't know.
Can x be minus 3?
No,
Why not?
because it doesn't cross minus 3.
Okay, what can it be? What x value can it take?
2.
Sorry?
2.
Yeah. And so how would you... Can it be 3? Plus 3?
Yeah, so is it just x greater than or equal to 2?
Correct. Go back to this thing over here. Why can't x be 1? Just in terms of the function itself.
Because you can't square root a negative.
Correct. That's why it can be 2 or bigger. Okay, any questions there? Okay. So a square root graph looks like this, y equals root x, and then you can just transform it. 2 to the right, 1 down. Another way to do it would be to sketch the first graph, the f of x, and then do a reflection in the line y equals x. That strikes me as more work. Okay, this is what it looked like. Okay. Let's try this one.
Okay, so y equals 3 over 2x minus 1. X equals 3 2y minus 1. If we do x plus 1, we get 3 over 2y.
The minus 1 is in the denominator, so you can't. That'll be breaking business.
Yeah, x equals 3 over 2y minus 1.
Yeah.
Do we just times it by 2y minus 1?
Yeah.
So.
And you don't need to expand it.
Yeah, okay. X 2y minus 1 brackets equals 3. 3 plus 1. Can I do that now?
You're still breaking business.
Oh.
It's inside a bracket.
B.
What can you get rid of first?
Can we divide by x?
Yeah.
2y minus 1 equals 3 over x.
Yeah.
Then divide by 2.
Young lady. No.
What's this? Okay, so can we add 1 then?
You could. It's much easier to add 1 first, because if you divide by 2, you'll get y, but you'll get minus a half, and I think you would have written down minus 1. Add 1 first. So the way you rearrange formulae is in the opposite order of Bidmas. So you have to follow Bidmas, but you do them in the opposite order. So do the adding and subtracting first, and so on.
So 3 over x plus 1. So 2y equals 3 over x plus 1. Then can we divide by 2?
Yeah.
Okay, so y equals 3 over x plus 1 over 2.
Let's just say times both sides by a half.
What? Oh, so 3. 3 over 2 x plus 1
3 over 2x.
plus 1.
If you half both sides, then you have to times
Half.
Yeah, plus a half. Okay, and lastly,
Then just do g colon x. No, g minus 1x
yeah,
equals that. Oh, that was so much of it.
domain.
Equals 3 over 2x plus a half. And then the domain, if it's x is greater than 1. Can you work out the domain without having to sketch a graph?
Possibly.
How?
Well, is there any obvious number that x can't be?
0.
Yeah. Let's see. So their graph here. So this is a reciprocal graph. I'd probably just put it in the calculator and get a table of values. So it's going to be a reciprocal graph. So it'd usually be something like that. because x is greater than or equal to 1, that means it's going to be something like that. And then get the possible y values as the domain for the other one. So for this graph, for the first function, when x is 1, what do you get?
Oh, that was me for a second. When x is 1, you get 2.
In the original function?
Oh, 3 over 2 minus 1, 3.
When x is 2?
Minus 1.
And so first you got 3, then you got 1. And so what does it look like the range is going to be?
Going to go down.
So x is greater than or equal to 1. What about y?
Minus 3?
Y is the possible outputs. So first we got 3, then we got 1.
Do I just work out what effect is 3?
Okay, so calculator time. Table. Fraction 3 over 2 alpha x minus 1. So
Yeah.
you wanted no diagram. Let's see, start from 1. So x starts from 1, and let's say it goes to 10 or something, going up in steps of 1. So we get our first two answers there. When x is 1, y is 3. When x is 2, y is 1. Then we get 0.6. What are these numbers getting closer and closer to as it gets bigger?
0.
Yeah, and that's because it's a fraction. And so what would be the range for the original function? If they start at 3 and go towards 0?
Okay, so is it just that x is greater or equal to 1?
Well, it can also be slightly less than 1, as we saw in the calculator.
Okay, so x in the middle, and then
this is y, just to be clear.
okay.
So x is greater than or equal to 1. What about y? What about the outputs?
Greater or equal to 0, and then
right. And what's the biggest number you can get?
3.
Yep. And so how would you write that?
So y in the middle, and then greater or equal to 3. No, less than or equal to 3. And then greater or equal to 0.
Yeah.
Wow.
Using that answer, what is the domain for the G inverse of x?
Greater equal to minus 3.
No, crazy talk.
I don't know.
Inverse function, x swaps with y swaps with x. Domain
So
swaps with range swaps with domain.
So they're just the same?
It's the same, yeah. So the domain for the function is the range for the inverse function. The range for the function is the domain for the inverse function.
Okay, so domain for function equals is a range for
Yeah. And actually I should just replace this with an x. It's not, yeah, it's just x. Yeah.
Yeah, the differential function is the range for the inverse function. So the range for the function is the domain.
Yeah. So you see up here we have like y is between 0 and 3.
Yeah.
For the inverse, you swap y with x. So x is between 0 and 3.
Yeah.
And that was illustrated, if I go way back. That was illustrated with this one. So basically, the domain is the possible x values for the function, and then those are the possible y values for the inverse, and vice versa.
Okay.
Yeah. So that's domain and range. Let's see. Sorry, let's composite and inverse. Let's just see. So composite functions, it's just a function of a function. And then inverse, you have a... Okay, hang on. Let's do it. Exam question.
F minus 12. Inverse of 12. Okay, f functions f and g time for all real values of x. Right, so f of 12 would be 12 cubed.
No, this is f inverse of 12.
Ugh.
Oh, okay, go on, do what you were doing. No, go on, do it. F of 12 equals?
Nah, I don't really want to do that.
Do it.
Okay, so 12 is equal x cubed plus 4. Yeah?
Right. So what's
And
the
then
f of 12?
The 12 cubed plus 4 is... Hang on, I don't know something about 1,732.
Actually, no, I was thinking of something else. No, you have to do it the long way, sorry.
Yeah.
I thought we could take our answer and sub it back. No, it's not going to work.
So, f inverse of 12 would be... Is it 12 equals x cubed plus 4?
That would be if the f of x is equal to 12. How do you find the inverse function?
We'll do the y equals x cubed plus 4 and then find out by there.
Yeah.
Okay, so y equals x cubed plus 4, then x equals y cubed plus 4. Then x minus 4, and I do that first. Yeah. Equals y cubed. And then cube root of x minus 4 equals y. So f minus 1 of x equals cube root. And then you just substitute 12. So you get... Oh, where's cube root?
It might be shift something.
No.
Is it shift square root?
2.
2? Okay, there you go.
You just get 2.
Any questions there?
No.
Okay, so there's more exam questions, but you have the gist of it. So I'm happy enough with composite and inverse functions. How about you?
Yeah, it's okay.
Okay, so they just need to be practiced. So I'm thinking next time we move on to chapter 3, or was there anything else that you wanted to do?
No.
Okay, so chapter 3 next time. Any questions for me in general?
What's chapter 3?